Hello and welcome to this video. I'd like to present just a really quick overview of this virtual laboratory that allows you to study the dynamics of this pendulum and block friction case study example. From the animations that you're looking at on screen right now, hopefully it's pretty self-explanatory. We have a pendulum which consists of a yellow rod with a point mass pendulum bob. The pendulum can swing and it can impact another mass, the green block mass. The green block mass is resting on a table and it can slide across the table. So the main focus of this virtual lab is studying the sort of friction effects between the green block mass and the table that it's sitting on. Okay, so there are 3 tasks in this virtual lab. We'll only talk about the first 2 in this video. In task 1, it's really quick. We simply introduce a MATLAB script that allows you to load into MATLAB's workspace numeric values for the model parameters that we've used to characterize the model by. How do you load into the MATLAB workspace a numeric value for the pendulum mass? How do you load into the workspace numeric values for the green block mass? So task 1 is about loading into the MATLAB workspace numeric values for our model parameters. The second task, we introduce you to the Simulink model that is a model of this pendulum block system. And we'll also look at the cause and effect workflow that you and your students can go through. All right, so let's look at tasks 1 and 2. So each task has its own dedicated MATLAB live script. So here's the task 1 live script. And as you sort of scroll down it, you can sort of see the instructions for what you need to do with this script. And for this task 1 script, it's nothing more complex than simply hitting the green run triangle, which simply runs the entire contents of the live script. So when you run this script, you'll see over on the right-hand side of the screen contents of the MATLAB workspace. We've now loaded into MATLAB's workspace variables that allow us to assign numeric values to our model. For instance, if I was to interrogate this variable called block, you can kind of see that it's got all of the numeric values for things like the mass of the green block and so forth. And similarly, if I interrogate the pendulum variable, you'll see, again, the pendulum's rod length, the pendulum's mass, the pendulum bob diameter. Okay, so this is all task 1 has done for us. We've just simply loaded into the workspace, MATLAB variables. These MATLAB variables are used by the Simulink model that we're about to look at next. So just let me sort of scroll down to the bottom of task 1, and I'll click on this link that says task 2. So here's the dedicated MATLAB script for task 2. And as I just sort of scroll down it, all this task is about is getting you to open the Simulink model of the system, and then we'll simulate the model. And then we'll look at 2 particular experiments where we sort of vary, the mass of the pendulum, the mass of the sliding block, and so forth. So as I scroll down it, the very first main step is to open the Simulink model, which is simply clicking on this button. There it is. And this is the Simulink model for this pendulum sliding block case study. Yeah. So this graphical block diagram is the graphical language used by Simulink and Simscape for assembling these physical models of mechanical systems. So in order to run or simulate this model, we simply go to the big green run circle. That would be this one. And we click on it. And when you do, this nice sort of CAD-like animation figure appears automatically. And as you can sort of see, it does a replay of the machine as it's sort of propagating forwards in time. And you'll notice some hopefully fairly explanatory, self-explanatory controls down here that you can sort of interact with a slider bar, and do a playback to sort of re-watch the results of the simulation. Okay, all right. So that was running the model out of the box. Let's go back to the task 2 live script. So the workflow of the task 2 script is there are 2 experiments. So let's just go through the first one. It's an almost identical workflow for the second experiment. But in the first experiment, what we're going to sort of do is we're going to go back to that MATLAB script that defined the MATLAB model parameters, and we're just going to sort of configure them. So we'll configure the pendulum bob mass to being 5 kilograms, and the green block that's sitting on the table to being 3 kilograms. All right, so let's go and do that. So here's our task 1 script file. And you'll see that the sort of parameters that we sort of want you to sort of interact with are kind of signposted by the slider bars. So the first one was the pendulum bob mass, M. So let's set that value to 5. And the block mass of 3 kilograms is already set. All right. So when you actually interact with these slider bars, what it does is it actually runs the MATLAB code within the script, so that in the MATLAB workspace now we have the updated versions of these variables that, for instance, has a value of 5 for the pendulum bob mass. All right, so we've got our experiment parameters already in our MATLAB workspace. Let's go to the Simulink model. In fact, I kind of think going to the viewer is a better option. If you go to the viewer, again, just look for that big green simulate icon, and that will simulate the model with these brand new model parameters. Yeah, so let's do that. Might kind of looked very similar to the previous one. If I was to really quickly go back to the task 2 script and have a look at experiment 2. In experiment 2, we're going to set the pendulum bob mass to 1 kilogram. So let's go to our parameter script, find that pendulum bob mass slider bar, adjust it. Our MATLAB workspace now has the updated versions of these model parameters. If I go back to my viewing window and click that green simulate icon again, you can see the cause and effect of this particular set of parameters. So there you have it. That's a really quick introduction of how to sort of interact with the MATLAB scripts and the Simulink model of this pendulum sliding block virtual laboratory.